Okay, so welcome everyone to the first of the SHAC online seminars of the new academic year. Despite the fact we're sort of moving into a sort of hopefully more normal period, we've decided to run the SHAC online, continue running the SHAC online seminars, certainly into next year, with the hope that possibly by the spring we might be able to have live meetings. So never know your luck. And obviously we've been talking about the possibility of hybrid meetings and so on. This seminar is being transmitted in two forms, Zoom and on YouTube. If you're on Zoom, after sort of the presentation, which will last about sort of 20-30 minutes, we'll have sort of 30 minutes of moderated discussion. And on Zoom, you'll be able to ask questions directly when you indicate you want to ask a question. On YouTube, you'll need to put the typed question into the chat box, and that will be passed to me to sort of read out. That's just one of those sort of quirks so that we have to live within our wonderful modern technological age. I think this is the first, well, no, I know this is the first dual presentation seminar in this series with Mariana Sanchez and John Christie. Mariana studied physics at the University of Paris and particularly interested in astrophysics, and she's now a PhD student at Paris Diderot, working on the present circulation of Paracelsian ideas in the Hispanic world from 1750 to 1700. She's also been working inter alia on the metallurgical writings of Alonso Barber and his Paracelsian influences, and some of that work was published in Annals of Science last year. John Christie describes himself as a retired, still active historian of Enlightenment science with particular attention to chemistry. He's recently guest edited an issue of Annals of Science on Atlantic chemistries, and a chapter in the Art and Representation section of Volume 4 of the Bloomsbury Cultural History of Chemistry, which we have been waiting with bated breath for some years now. And he writes, hopefully it will be appearing towards the end of this year, so get your Christmas present money out for that. In terms of SHAC, he organizes the Oxford Seminar of History, Alchemy and Chemistry, which is sponsored by SHAC, by the Maison Française in Oxford. The title of John and Mariana's talk is Discreet Charm of Platinum, and John will bat first. John.
Thank you. Joe, could we have the first slide, please?
Yes, let's try to share it. Yes, can you see it okay?
No.
Now it should be okay.
Yes, there it is. Thanks very much, Joe. Thanks very much. Well, hello, everybody. Thanks to all for coming. Quick thanks to SHAC in general, to Frank in particular for the invitation to speak, to Joe Hedison for the poster publicity and for acting as mission control of this seminar. And my personal thanks go to my co-speaker, Mariana, whose original conception the discrete charm of platinum was, and I only joined the project latterly. I'm going to explain briefly why we are saying the kind of thing we are saying, and it's because Discrete Charm of Platinum is written for a project called Materials and Time, which was originated by our French colleague Bernadette Benso Vincent. It's a multidisciplinary project, and it involves working material scientists, archaeologists, anthropologists, as well as a good number of historians of science. Now, it's not simply another materiality project. The focus is definitively on what we are calling temporalities, and temporalities have wide-ranging exemplars. We try not to be dogmatic about what constitutes a temporality for any particular participant. These might be temporalities exerted through the properties of a particular material. They might be temporalities to do with things such as business cycles, production cycles, materialities to do with the way in which particular materials enter the life of communities, and come to have ceremonial and personal meetings. It's the temporalities which rule the project, so we can have, you know, a very mundane temporality like concrete aging, yeah, or an exotic one like African wild silk. It all depends on the interest and the focus of the temporalities. And that's what we are going to be talking about with reference to platinum. And we begin with supernovas and we finish with Massacre. So, Joe, next slide, please, for Mariana.
Thank you, John. Platinum is a precious transition metal, a noble metal, and it is one of the rarest elements in the Earth's crust. Only 100 tons are produced annually on average, and it is one of the least reactive metals. Platinum is remarkably resistant to oxygen and acidic corrosion and to high temperatures, having an exceptionally high fusion point. Platinum, like gold, is a heavy metal that is not formed in the stars through the normal process of absorption of neutrons. In the stars, the fusion reactions turn light atoms like helium into heavy atoms like iron or nickel. But during the slow neutron capture process, some other heavy elements like mercury or tin can be formed. It is only in the most reliable theory now in the supernovas that a fast process of neutron production takes place, and the atoms are forced to absorb those neutrons in large quantities before radioactive disintegration. This is how the heaviest but stable elements like platinum are formed. Thanks to the rotation of the disk that originated the solar system and its gravitational forces, the proto-Earth becomes spherical, and the heavy metals sink to the nucleus of the Earth. Crucially, some 4 billion years ago, an event known as late heavy bombardment occurred. During this period, the number of meteoritic impacts grew considerably, probably because of the organization of the outer solar system. The impact of these comets and meteorites changed the composition of the Earth's mantle. Precious metals found today in mining deposits come possibly from those impacts. Platinum goes to the Earth in these two ways, and it is possible to find it in two types of deposits: in the mantle, coming from meteorites, and in volcanic deposits. Today, platinum is employed as a catalyst, as well in the automobile industry and the manufacture of fertilizers. It is also used in the production of electronic components, plastics, synthetic fibers, and pharmaceuticals. Platinum is also present in the manufacture of optical glasses and fuel cells. It is used in almost half of chemotherapy cancer treatment in platinum-based antineoplastic drugs like cisplatin, oxaliplatin, and carboplatin. Next slide, please. Since 1957, platinum has its own journal, the Platinum Metals Review, but it is accepted that the first written reference to platinum appears in 1557 in the Exotericarum, written by the Italian physician Giulio Cesare Scaliger. He tells of a metal found in the New World that the Spanish were not able to liquefy. Scaliger knew about this metal because of news coming from the Americas, but it was also mentioned by José de Acosta and by Álvaro Alonso Barba, who explored and worked in the Indies. However, it is not until the mid-18th century, with the voyage of Antonio de Ulloa and Jorge Juan y Santa Cilia, as part of the French geodesic mission, that the first samples of platinum arrived in Europe, and with them the interest of studying this resistant material. Ulloa traveled from Cartagena to Quito, and during this voyage he went to Chocó, a region of what is today Colombia, where through gold panning was found another metal that looked like silver but was harder than gold and very resistant to heat. It was not possible to melt it with the technology of that time. Ulloa, in the Relación Histórica del Viaje a la América Meridional, explains that in those mines there was a mineral called platina, which we might translate as piri silver. It was very resistant, could not be broken, crumbled, or melted, so it was often necessary to abandon the mines because it was very expensive to extract gold in presence of this platina, a process undertaken by mercury amalgamation. Because of this official mention of the existence of the material, Ulloa is considered today as the discoverer of the platinum. It is important to consider that in his report, Ulloa puts platinum as a subject of interest for science because of the difficulty of treating it like gold or silver. During the voyage back to Europe, his ship was seized by the British, and once in London, Ulloa met Martin Foulkes, president of the Royal Society, and Ulloa became a member of the society himself in 1746. Next slide, please. Today, platinum is found mostly in South Africa, with more than 70% of the global production, but also in Russia, Zimbabwe, North America, China, Colombia, and Finland. In South Africa, it can be found in the Usual Igneous Complex, or BIC, the largest igneous intrusion within the Earth's crust, which has been tilted and eroded, forming the outcrops of what appears to be a great geological basin called the Transvaal Basin, which is about 2 billion years old. The BIC contains some of the richest ore deposits on Earth and the world's largest reserve of platinum group metals. In Russia, the principal source of platinum is the Condor Massif, the only circular mountain ridge in the world, which most probably formed from a dike. The platinum there comes from the core of the planet. In Chocó, Colombia, where platinum was discovered, the principal hypothesis was to consider the alluvial origin of the metal, but evidence has shown the pyroclastic character of the rocks containing platinum, many of which probably come from the inferior Cenozoic era, when great magmatic activity took place in the West Andean mountains. Yeah.
Okay, thank you, Mariana. Mariana has moved us from these dizzying temporal perspectives of incalculably distant and remote times through to geochemical times on our local parochial planet Earth, and has moved us into the time of human acquaintance with and then study and knowledge and science of platinum, and that's where I take things up. covering what I am calling refractory times. And I'll do this partly through the figure of William Lewis, a well-known practical chemist of the middle decades of the 18th century. Here you have pictured his laboratory. He obtained quite substantial samples of the metal early in the 1750s and commenced a long sequence of experimentation on it. That was read and then published, Royal Society of London, received the Copley Medal, importantly. And he continued his work on platinum through the 50s and into the early 60s, eventually publishing 171 pages of it in his large work, the Commercium Philosophico-Technicum. That, I think, for the middle decades of the century was the most thorough and the most authoritative work available on platinum. I take the term refractory from William Lewis. He uses it to refer to platinum's discrete nature. Its incredibly high fusion point, its ignoring of all acids other than aqua regia and other acids, and he and also, yes, one mustn't forget it, its non-combustibility. It doesn't oxidate it. Now, this, of course, makes it A, a very interesting material for chemists, but B, a quite incredibly difficult one. Samples were very, very difficult to get hold of. They're smuggled from alluvial sources in the north of South America. They then have to be processed to obtain metal. This processing is very, very difficult indeed. It's achieved by a sintering process, that is amalgamating tiny grains of platinum and then compressing them. You get this spongy mass of it, then you sinter it, compressing and heating it, and eventually, if you are lucky, you can get a sort of workable metal or tiny samples of it. Lewis's work is just great for taking you through all these problematic features. It's very, very thorough. But the underlying question that I think Lewis poses is, what is it good for? You know, how can you work it? How can you use it? He concludes it's of negative value. This was the same conclusion as the Spanish in South America and also in Spain, because its main use, if you had enough of it, promised it to be an adulterant for other precious metals. That made it of negative value. So the Spanish tended to throw their platinum grains in South America back in the river. Some of this gets smuggled to Britain. It's already contaminated with mercury because it's been used in mercury amalgamation process to produce gold. So it has to be cleaned. It's a very problematic process. Even if you've got the metal samples, what do you want from a metal, from a precious metal? It has to be malleable, that is shapeable, moldable, and it has to be ductile. You have to be able to stretch it to draw it out. There is some success. There is British, French, Spanish work after 1750, but it only produces very small amounts. So you get what are called buttons of platinum. You occasionally get something as large as a sword hilt. But that's where we are. This only starts to change in the 1780s in Spain, which Mariana will talk about shortly. The British story goes on and begins to change very substantially with the work of Wollaston in the 1800s and the 1810s, who produces a sintering process which has a much, much higher compression rate. And that is why I've included the image of his toggle press from the Whipple Museum in Cambridge. It had a much higher compression facility as a device than any previous. And he is able to ensure a supply chain and to produce substantial quantities. The markets it went into are interesting. Jewelry, first of all. Secondly, it was used for touch holes for firing firearms because of its resistance to temperature and corrosion. Thirdly, it becomes used in chemical industries because it is so resistant to acids. That's the point. So instead of using lead vat processes, chemical industries, if they can afford it, it's still very expensive, switch to platinum vats. So notice what has happened. It is precisely the refractory properties, yeah, the resistance to acids and temperatures, which provide the entry points to the industrializing market of platinum. That's the point I really want to leave you with. There's a bit further to add about this period, about catalysis, but I'll leave that aside for the moment. We can come back to it in question time if anyone wishes. And could we switch to Mariana now again, please, Joe? Thank you.
So, thank you, John. So yes, in Spain, a French chemist called Pierre-François Chabanot was noticed first by a Spanish aristocrat who came to France looking for a professor of physical sciences. And then he was also noticed by King Charles III of Spain he wanted to share of the public teaching of physics in Madrid when he was in Spain. So during his time there, he develops a method to obtain ductile platinum without completely realizing that there were 6 other elements in the metal. In 1783, he produces an ingot of he called that platina. So it's still a pretty silver. And with that platinum, he produced some metals and a chalice that was presented to Pope Pius VI. And after that, so Chabanot became director of the Laboratorio de la Platina. So it's still nothing very precious. So this laboratory had the mission of the purification of platinum that arrived from America, and to train some chemists to do this work. But it was really important to the Spanish government to keep this method secret. During the same time, another French scientist, Joseph Louis Proust, got another sample of the metal. And he realized that aqua regia did not dissolve the whole sample. So there was the idea that other substances stay with platinum at that moment. So it was like a new discovery at that moment. Can I have the other slide, please? Thank you. So because platinum is very resistant to oxygen and to corrosion, it also later in the 18th century became the material to do the international prototype of the meter and of the kilogram. The prototype of the meter is a measuring rod that was used as a standard of the construction of all other length measurements in the metric system. In 1790, the desirability of a uniform system of weights and measures that could be applied worldwide was discussed. So therefore, it was necessary that it was based on some invariable unit of nature. In addition, it had to be very easily reproducible and measured with high degree of accuracy. The unit of length was to be a portion of the circumference of the Earth. The first standard meter was deposited in the archives in Paris in 1796. And today it is housed in the Conservatoire des Arts et Métiers. So this is a platinum rod that still exists. We cannot see it actually. It is very protected, but there's another rod that is exposed in the Museum of the Arts et Métiers. In 1960, during the 11th Conference on Weights and Measures, a new definition of the mirror was adopted. So it was based on the wavelength in Bacon of the orange radiation of krypton 86. And in 1983, during the 17th General Conference, a new definition of the mirror was decided, and it was defined according to the light, the speed of light in a second in Bacon. And the kilogram is the basic unit of mass in the International System of Units. On 1875, the Mirror Convention formalized the metric system, and the mass was redefined as the kilogram, not the gram, which became the only base unit with a multiplier prefix. The international prototype of the kilogram is one of 3 cylinders made in 1879. And the prototype is made of an alloy of 90% platinum and 10% iridium. The addition of iridium greatly increases the hardness of platinum, while retaining the properties like high resistance to oxidation, very high density, electrical and thermal conductivity, low magnetic susceptibility. The kilogram, the prototype of the kilogram and its 6 copies are stored in the Bureau International des Poids et Mesures, each protected by 3 glass closures sealed with a special controlled environment. Also in the Conservatoire des Arts et Métiers. And since 2019, the kilogram was redefined according to the Planck constant. Thank you. John?
Thank you. Okay, I am now taking up the theme of imperialism, which Mariana has introduced us to, with the Spanish empires tend to attempt to monopolize it in the 18th century. The next phase is British, and it is centered on South Africa and the pursuit of the quite enormous valuable mineral resources of Southern Africa, which was part of the motivation for imperial expansion there. Particularly in the first instance, gold and diamonds, but there's also nickel, there is copper. And in the 1920s, there is platinum. Now, what this meant is that platinum as a material mined and produced in South Africa becomes part of South African political economy in the 20th century. That means it becomes part of a system of racialized capitalism, in a system of coercive migrant labor, where workers move to mining areas, from their bantustans, their designated so-called homelands. The workers are kept in rigorously policed compounds and rigorously policed shift work. This history of the bantustans and apartheid is well known. The labour processes for platinum are also well dealt with by African political economists. Things improve in the 1980s with the end of apartheid, and there are genuine gains made for the indigenous platinum workers by the increasingly powerful National Union of Mine Workers of South Africa. Platinum then enters a massive boom phase in the 1990s and early 2000s. That is pushed along particularly by its growing role in automobile exhaust catalysis. These are fantastically profitable boom years for platinum, quite extraordinary profit ratios. And it all comes tumbling down with the 2008 crash, where platinum profits nosedive and completely flatten out. That immediately has an impact upon the extraction labor force. The miners underground, the platinum rock drillers. There is increasing union activism, union unrest. And this ultimately results in a dreadful episode at the Marikana platinum mine, which was and still is owned by Lonmin, a London-based corporation, Anglo-American finance, a direct lineal descendant of a company which people my age remember from the 1960s and 1970s, Lonrho. Eventually, there are wildcat strikes, things get out of hand, there are weapons, the security forces arise, and there is a literal massacre of the platinum workers at Marikana with 34 killed. And this is the most dreadful moment, I think, pausing point in platinum's history. And it's very recent, it's in all of our lifetimes. And I end imperial temporality with that thought. And just to move to our final slide to conclude, if we may, Joe. Thank you. Okay, well, we have concentrated on a variety of temporal modalities, those exerted by platinum itself because of its refractory resistant nature. And we've moved from there to temporalities of experimental inquiry and increasingly successful material productions, those being very tangled, very entangled with the imperial histories of Western Europe. We've stopped with little punctuation points. The Marikana massacre is an obvious tragic punctuation point. One of my favorites is Chabonneau back in Spain in the 1780s, becoming frustrated with rage at the refractory nature of platinum and hurling his laboratory equipment out of the laboratory and saying he'd wasted his life. Let's have another final punctuation point. This is a poem written by Arisitas, professor of sociology in University of Cape Town, but also a notable poet. And it unites two temporalities, the longest temporality of human use of platinum, namely for personal and ceremonial adornment, and the imperial the imperial temporality as well. My love, did I not gift you a necklace with a wondrous bird, pure platinum to mark our bond? Was it not the work of the most reckless angel of craft and ingenuity? Was it not pretty? Didn't the bird have an enticing beak of orange with a green tint? Throw it away quickly tonight. It will turn nasty and gouge a shaft into your slender neck, and it will hurt because our metals are the hardest. Gold, pig iron, manganese, yes, platinum. Humanity has somehow died in Marikana. Thank you. We're now open for question and comment, Frank.
Thank you, John and Mariana. Really, really interesting, engaging, and seminar. I've got lots of questions, and I shall exercise my normal chair's prerogative and ask the first one, and that's about Marikana. What sort of inquiry and liability was sort of happened afterwards, or I mean, it's only 9 years ago. That might still be going on, I suppose.
Yes, some of it is in fact still going on, particularly the photograph I had of the victims on the last slide. The attempt to obtain justice for the Marikana victims and for their dependent families. The whole situation is in fact a very contorted and complex one, Frank. I think it's a legacy of the long imperial dominance, the migrant labor system, reaching this flashpoint after the crash of 2008. Some of you may have heard of Cyril Ramaphosa. He was president of the NUM in the 1980s and a highly active, successful president on behalf of platinum workers. He later became secretary of the African National Congress and in fact for I think a quite short period succeeded Jacob Zuma as president of the South African Company. But between his great union activism in the 1980s and 2012, he had joined the board of Lonmin, and he actually criticized the strikers of Marikana quite harshly. He later withdrew it, but this kind of story is replete with all these complicated conflicts, and you know, some strikes have continued. It is somewhat more settled now, but you're quite right to pick that up, Frank. It's exactly the case. Yeah.
Depressing, isn't it, really?
Yes, it is.
So, Simon Werrett has got to set up. You need to demute.
Right, that's better. Thank you very much indeed, Mariana, John, for a very interesting paper. And yes, as you say, pretty depressing story. Made me think of a paper that Lisa Roberts and Joppe van Driel did in a book called Compound Histories that I edited with Lisa a few years ago. And their paper was about coal, the history of coal. And one of the things they said which struck me was that the identity of coal as a substance was a product of exactly this kind of industrialization, commodification happening in the 18th and 19th centuries, such that you know, as people started to argue over it in the courts, in the government, so the definition of it had to really be pinned down, and so the idea of it as a particular kind of substance is a product of those processes. So I just wondered if is that something one could also say about platinum, or is there something about platinum because it is this sort of, it does have this very kind of intransigent quality to it? Has it always been platinum, or does it emerge in the same way that coal emerges?
Mariana, would you like to have a go of a first answer to that?
I think it's a bit of both, because it was like we said, it was not a good material to have in the beginning, so it was really something to reject. And it was really later in the late 18th century that we started to realize the use of platinum, the characteristics of this material that was not platinum yet. As I said, it was platina, something not yet very good, that it started to have a new identity at that moment. And we started to use it like for this chalice presented to the Pope. So it was used for jewelry, but it started to have this identity late in time.
Yeah, and I could just add a few points or two backing it up. You see, many of the 18th century samples will not be absolutely pure refined platinum. In particular, they once you've got rid of silicates of iron, it may still be blended with metals that come from what we now know as the platinum group. You can picture it on the periodic table, and the early 1800s see the beginning of the separate identification of the platinum group metals, first of all with Smiths and Tennant working, I think it's, is it osmium and iridium that are identified, and there's parallel comparable work going on at the same time in France. So the identity is very, it is a very staged and staggered process, Simon, I do think. Yeah, so thank you.
Thanks.
Actually, the next question relates to that from Alexander Angerhofer.
Yes, can you hear me?
Yes.
So I was interested in the malleable platinum. I presume it's an alloy. Is the composition known?
I think it's like 90% platinum, and the 10% restant, it was the other 6 platinum group metals, yeah. But I'm not sure it was, it is not the exact composition of the others, but I think it's, most of it was iridium, but I don't think it is known exactly. At least I don't have it. I remember that it was 90% platinum.
Yeah.
So are there samples left that one could study?
I think there are, but they're not accessible to normal people.
There was some of Faraday's platinum in the Royal Society collections, but I don't quite know whether that's still there. It's one of those sort of things. The trouble with platinum is because it's so valuable. Sticky fingers.
Thank you.
Andrew and then Hasek. Andrew. Andrew?
There I am.
Ah, yes.
Yes.
Okay. Go ahead.
Let me just read it from the chat here. It looks like there was a lot more platinum available and in use during the 19th century. I was looking at, a meter, and then you have the kilogram samples. Were there new methods of extraction and refinement that made for a more abundantly available platinum?
I think there's not much more platinum available. It's just that we learn how to extract and refine, because it was in the 18th century that we but with the Chabano and later to have ductible platinum, so we could start using it in other ways.
Yeah, I think you know, certain kinds of demand are growing in the 19th century. That thing I briefly mentioned about emergence of its of platinum's catalytic properties is, I think, important. I think that's important there, and also refining processes. Getting furnaces with the capacity to render it malleable and ductile. In the 18th century, the furnaces would char or melt or go on fire before the platinum did. You know, it was very, very difficult. But you get, by the 1840s, certainly in France, the creation. There's a very interesting lime block furnace that is created that enables you to really melt the platinum and run it off. So by that time, the 1840s, certainly, you're starting to be able to process more of it at very, very high temperatures. Yeah, thank you.
Yeah, thank you.
Thank you.
I have a pair of questions about the use of platinum. One is about, well, there's a legend which I've seen about Wollaston that he made good money by selling platinum crucibles and spoons and such to fellow chemists. And to what extent was that true, and did that, you know, research use of platinum last much beyond his time? You mentioned industry, but not so much the scientific use. And the other is in the later period, you know, the use of platinum as a catalyst. You mentioned the very modern usage, but it was, right, a 19th century discovery, right? And how much development of that catalytic use was there through the 19th century?
It's a good question, Hassel, and I don't know if I'm altogether competent to answer it. I don't count myself an historian of 19th century chemistry, really. What I think is interesting from the catalytic point of view is the emergence of not just the catalytic properties of platinum, but the relative centrality of platinum as deeply involved in the actual historical emergence of the very concept and process of catalysis. That's one thing which I think is well worth emphasizing. I'm just not sure which catalytic properties and for the production of what, say in the period 1850 to 1900. And also, I certainly think the story of Wollaston and the instrumentation is true. He did make them and people did have them. But how much, and obviously it's brilliant for crucibles because of the temperature resistance and so forth. Whether it was at all profitable to expand, as it were, a scientific instrument business, I do not know. I somehow doubt it because I'm not aware, not that I'm a great expert on 19th century instrumentation, but I am not aware of a substantial laboratory presence, put it that way. That may be in error. Mariana may have greater knowledge than me. Mariana.
No, actually, about the 19th century, I don't know either. For my studies in chemistry, I kind of know a little about platinum using catalysts, but more recent times, like recent times, but no, in the 19th century. I'm sorry, I don't know.
Yeah, thank you.
So there's a comment from T.H. Rian, if I got that right, from UCL, which should go in. Would you like to sort of make that comment?
Well, yeah, just to point out that on the Russian side, obviously Russia with their own massive deposits in the Urals, where parallel developments quite successfully processing that raw platinum, bringing it up to a quality of 99-98% pure platinum, stripping out all the other PGEs and iron down to a fraction of a percent, roughly, and making a circulating coinage out of it, which was in circulation for, I've forgotten now, 10, 20-ish years, pitched between gold and silver. Population never liked it. And then eventually they withdrew it because it just wasn't taking on, and then sold the stuff to Europe, where it was then processed for industrial application, from what I understand. Very few of those original coins persist. Most existing ones in collections are later reproductions. But the scale and the cleverness of his process is really impressive, I thought.
Well, thank you. That's a very valuable comment, and apologies for not mentioning the Russian developments, because it was important, and particularly the success in being able to process enough to create a coinage out of it. That I think is, you know, a very, very striking feature. I myself am not sure how Russia managed to get such a purified form of the metal, how they did that. It's very interesting, though, for the chemical.
It's documented. He set up a laboratory,
yeah,
with a chemical process, dissolving, reprecipitating it, burning off the precipitate,
yes,
hexachloroplatinate or something.
Yes.
So he developed it, and they applied it in Russia, in St. Petersburg.
Yeah.
It's not that they learned it from elsewhere.
Yeah. Yeah. Thank you very much.
Thank you. Mark Grossman's got a sort of comment and question, I think.
A comment question. I believe the French had tried using platinum for reflecting telescopes in the late 1700s. And I was wondering if anybody could comment on that or have any information.
I have no information. I find it very interesting.
Yeah, but I will look.
There was an article published by Seymour Chapin back in the 1970s that discussed that, and it just came across my attention, and I was wondering if if anybody had any additional information on that.
No, I'm interested in mirrors in relation to platinum, but I hadn't come across the reflecting telescope example. But what the French did earlier, this was still, I think, just in the 1750s, they did achieve some success by using a very large burning mirror to focus the heat and get a relatively pure metal, but again, not on any scale. It's interesting that the production has been scaled up, and polishing and surface forming has developed for platinum. Did you say by the late 1790s? Yeah, okay, thank you.
Okay, so now there's a YouTube question from Stefan Macrae, which I shall read out. According to you, with the new technologies developed in the automotive industry, do you think that use of platinum should decrease or remain identical as now? Future question rather than a historical question.
Mariana, any thoughts quickly?
I think I don't know for any other place right now, but I think for the Paris context, I think we should maybe stop using cars because the public transportation is good enough. So maybe the use of catalyst for transportation, private transportation should be decreased in that way. But I think platinum is very expensive to use only in cars. You know, you have to develop in other ways.
There have been cases I've read in the papers about people stealing platinum catalytic converters off cars. So somebody comes out in the morning and BMW or Mercedes can't work because it doesn't have a. I mean,
if I could just comment exactly on that, Frank, because this hits close to home. Not my own car, but my daughter's car was done that way. About within the last 3 months. The catalyzer, it's just, you know, they opened the car and the bonnet, took it out and gone in practically a matter of seconds. I think I do have a further thought about materials and automobility, having come across but not read a very recent book published in August on lithium, and it is a kind of lithium temporality book because it's focused on the future and says it is the coming material as Chinese car manufacture in particular, and lithium production, again in South America, invested in with billions of Chinese pounds, will take over the use of electrified automobiles. So we may be, as it were, moving from platinum catalysis insofar as automobiles survive, to lithium.
I mean, I suppose as a sort of closing question, could you do, and I mean, Simon mentioned earlier about sort of similarities with coal, could you tell similar sorts of narratives about other chemical elements or indeed chemical substances, compounds generally?
Mariana, do you have any other materials in mind with comparable stories?
I cannot think of anything right now. No. I just remember, you know, as I work on silver about Álvaro Alonso Barba, his book, for example, in Spain had the same problem of Chabanu. This book was not supposed to be published and spread. Actually, his method did, but history of other materials like that, I really have no other idea.
I've been trying to think of, well, it depends, I suppose, Frank, what the standard of comparison might be. You know, one could think of, you know, the other precious heavy metals, the platinum groups, gold and diamonds in particular might equally reflect the imperializing themes which Mariana and I have emphasized. Coal itself, at least in British terms, reflects the labour force and strike history for any viewers like me who remember the Great British Coal Strike of the 1980s as a political culminating point of something. I think it just depends upon the kind of vector of comparison you're going to choose, Frank, but I'm sure there are comparable stories to be told. So thanks for the idea.
Yeah, so that's provoked quite a lot of discussion in the chat box. So Joe said gold, Thilo said phosphorus, tungsten, aluminium, you name it. So there's clearly some ideas out there. So unless anybody's got one final question they're burning to ask, I will draw things to an end by saying that the next seminar in this series will be by Vivian Quirk from Oxford Brookes University on the 25th of November at 5 p.m. Greenwich Mean Time, as we will be on Greenwich Mean Time at that point. And so just finally remains for me to thank all the people who've been involved in producing this seminar, these seminars as a whole, because it's quite a lot of work that has to come together into sort of one pretty smooth, seamless operation. So particularly Rob Johnson, Anna Simmons, Caroline Cobble, Becky Martin, Chris Campbell, Joe Hedison, technology today. And last but by no means least, John and Mariana for giving us a really good seminar. It was a really nice discussion. So thank you everybody, and have a good evening or morning or afternoon, depending on where you are in the world. Thank you.
Thank you. Thank you very much.
Thank you, Mariana. Thank you, Frank. Thank you, Joe. Thank you all. Good comments, everyone. Thank you.